Welcome back to the next session. The next session of the Cybershock will most likely not shock you because you've heard the name before, Emotet. Our next expert is one of the experts in the world who is diving into this piece of malware. I welcome on the stage James, who is going to do a very deep dive into Emotet's email stealer module. James, the cyberspace is yours.
Thanks for the intro. So my name is James Quinn. So I'm going to be giving you a deep dive presentation onto Emotet's email stealer. A little bit about me. I am a threat researcher and malware analyst at Binary Defense, which is kind of a vague term, but it basically just means that I spend a lot of time researching malware and then writing detections and then implementing those detections in various client environments using a variety of endpoint detection response tools. In my free time, I'm a cryptolimus researcher. So I track Emotet. I have a full Emotet emulator, so I receive like spam and everything from Emotet. But then also, and just a little fun fact about me, work from home has led to some very interesting changes in my wardrobe. It's been a while since I didn't wear PJs. No real reason to dress nice if I don't leave the house. But yeah. So just for a little outline of what we're going to cover today. So first, I'm going to give just a brief intro on Emotet. Most people should probably know what it is. But then from there, I'm going to talk about Emotet's email stealer and just how it kind of functions and some brief rundown of the key points of it. But then I'm going to get an intro on COM objects, mainly from a reverses perspective, which is going to be a lot more brief than programmer's perspective, because I don't actually need to use COM objects. I just need to know what it looks like on the assembly level. And then I'm also going to walk you through how you can find those COM objects that aren't found in IDA and how you can fix them manually, and then how you can also fix them automatically through IDA. And then I'm also going to give you some resources for MAPI COM objects specifically. And at the end of all of this, I will be, Dr. Bernhard will be distributing a .h file of all of the COM objects that I import and fix manually, so you don't have to go find them in the .h files. And then from there, we're going to go through a walkthrough of the main email stealing code, and then we're going to open it up for some questions. So just to give a brief description of Emotet, it is a very prolific and quite dangerous mouse spam botnet. It's pretty huge. There's actually 3 individual botnets. They're divided by epochs, as in like the geology epoch term. Epoch 1, Epoch 2, Epoch 3. And the campaigns that each epoch runs will be different than the other epochs at the exact same time. So the primary purpose of Emotet is to load other malware. That seems to be their main money-making venture. And then they'll use other modules that they load before they load other malware to strengthen the spam capabilities. Or it'll also strengthen the infection capabilities. So the spreaders, for example, are strengthening the infection, but the email stealer is strengthening the spam capabilities. So there's a lot of features to Emotet. So the specific module that I'd like to talk about, because there are about eight modules, is Emotet's email stealer module. And so the email stealer module is just kind of a quick rundown. It accesses Outlook through the MAPI subsystem, and that is accessed through the MAPI32 DLL. And so the way that it actually accesses this DLL and identifies it is through a registry key, the software client's mail Microsoft Outlook key, and in that key will be a value that has like image path, and that'll be to the DLL. So that's how it identifies MAPI32. If you don't have Microsoft Outlook on your computer, it won't actually run because it needs Microsoft Outlook. But so once it gains access to the MAPI subsystem, the email stealer module will then steal all emails in IPM root with attachments that are 131,072 bytes in size or less. And it doesn't look for it. The emails don't have to have attachments, but if it does have an attachment that's larger, it won't steal that attachment. It'll just steal the email. And so now I'd like to give just a kind of brief rundown of COM objects. A deep understanding of the component object model COM is nice. Time both in this talk and in life is fairly short. So the key things to keep in mind is that COM objects are identified as interfaces made up of methods. And so if you aren't as familiar with programming terms, because like for example, I don't have a background in programming, I just taught myself assembly. If interfaces can be thought of as sets of functions, whereas methods can be thought of as individual functions. So it's COM objects are made up of function sets and made up of functions. So luckily for normal COM object reversing, IDA automatically defines several of these COM objects in the structure database. And then there's a GitHub tool that provides a lot more. The tool is out of date, so you'll just have to use it as a reference. But unfortunately, the tool doesn't cover everything. And especially when I was analyzing this email stealer, I realized, wow, the MAPI COM objects are not documented whatsoever. So you'll run into problems later on. But so when we are able to find and fix COM objects in IDA, it's actually a fairly simple process, and I'll give you a demonstration of this later on. But so just for a brief rundown, you can define structures with the add struct type option in the structure view. And so you right click and then you select add struct type. And then there will be a button that appears in a new dialog window, and or there will be a new dialog window that appears with a button that says add standard structure. And that can be used to add an existing struct in IDA. Once you've added a new structure into IDA, you'll need to change the alignment on the structure. If you're working with 32-bit, you'll need to change it to 0x4. If you're working with 64-bit, it'll need to be 0x8. And so now that the structure itself has actually been defined, you can then start defining each of the methods inside the structure. So for that one, you need to keep one thing that you have to keep in mind when you're defining COM object structures for IDA is that all COM objects will have 3 base methods. There's query instance, add ref, release. They have to be in that order at the very beginning of the COM object interface. And these are all built into every single COM object in Windows. So once you've fixed up the structures in your structure view, you can then go into IDA, and you can actually fix the COM object calls so that it makes it easier to read. So for example, in this one, it's called dword pointer ex14. It actually gets changed to the IMAPI container vtable get props, which is super easy and super analyst friendly. And I will show you how to do all of this. So some resources specifically for MAPI COM objects, because MAPI COM objects are not easy to find. After lots and lots of searching, I eventually found out that the MFC MAPI dev, Stephen E. Griffin, provides most of the 8.h files that you would need to reverse MAPI COM objects on his GitHub. The link is right here. And one thing to keep in note when you're looking at MAPI COM objects, you want to also find and identify where the property tags are. As these are if I were to make a comparison to HTML, property tags are basically HTML tags. They identify what is being accessed in the email object. And so they're a 32-bit number, and bits 16 through 31 are a unique property identifier. And this is defined in MAPI tags.h. And then bits 0 through 15 are a property tag type identifier, and this is defined in MAPI defs.h. The only one that's really important for reversing is the unique property identifier. So you don't really have to find the tag type, but that's the only one that's really important. And then also, when you are reversing COM objects, you probably need to use MSDN as a reference, because they don't always list out that this call is going to specifically result in the new COM object, which is one of the challenges with reversing COM objects. So just to go over, these are the COM objects as you will encounter when reversing Emitet's email stealer. So this is the profile admin COM object used for profile administration. This is the MAPI table used for parsing the MAPI database. MAPI session is for MAPI connections. Message store contains information about the messages. Address book is, of course, the address book. And then IMAPI container is another special container used for processing folders. So now we've gotten to the point where I'm going to switch over to the analysis walkthrough. The sample is available on Malwarebazaar, and the hash is right here. If you'd like to pause the, if you're watching from home, you can pause the video here to copy the slide or to grab the hash. If you're not watching from home and you have the sample, the analysis starts at 0x34E0 in the binary. And I will share to the other IDA screen. All right, so this is the binary that we're going to be analyzing. And so just starting out, before we even dive into this whole thing, so I'm going to first go to the entry point of where we're going to be starting from, which is right here. Yeah, so this is the entry point, but where we're going to be starting from. However, before we actually dive into analyzing, I'd like to first give you a rundown on how to actually import structures into IDA. And so if we go into the structure tab, you can see that I've already imported a lot of these structures. But so this is kind of how you add in a structure into IDA. So first, if we right click and go to add struct type, then we can go to add standard structure. And so this actually shows the interfaces that you can add as a COM object. There are quite a few here. I'm gonna just go to, we'll just select DLG, or we'll just select this one right here. When you are adding things from the IDA structure database, make sure to add the V tables instead of the actual, instead of the base structure, because the base structure is just a reference to the V table. So in this one, DI system monitor events V table. And so if I hit Control Numpad plus to expand, you can then see that these are all of the methods available for the DI system monitor events COM object. And now, if you need to declare a COM object or create one that doesn't already exist, so say for example, because this one's red, it means that I imported iProf admin doesn't already exist. You go to add struct type, and then you just name it what you want to name it. I'm gonna hit OK. So now we have this blank empty structure with no alignment. So now we have to go to edit struct type and then change the alignment, since we're in 32-bit, to 0x4. And now we can actually start to add in fields. So we're gonna just, if you hit D or if you right click it and select data, you can add in a new field. And then I'm going to rename this field as, since this is a COM object, I'm going to rename it query interface. And we're going to add on the next field with D. And then we're going to rename that one to addref. And then we're going to add on another field for release. And there we go. This is our COM object. And so now if we wanted to use this COM object, I would go to, say, this call right here. Let me change that. So if I wanted to use this, I would select here. And so I actually don't have, I didn't declare enough functions for this. Hang on. So we need a fourth function because that was an offset of +10. But now we have test. If I go here and structure offset, I can actually just select the table that I just created with we're gonna just go with the one that I created in the test. But so this is the test COM object. I am not a COM object. You can see that this one right there is connect to server. Connect to server is the last one. It was +10 offset. So it fixes up automatically. So this one was actually IMAPI table get or this is the iProf admin get profile table call. So that's kind of how you fix the tables. And so if you saw, I right clicked it and went to structure offset to fix the COM objects. And now if you also notice, another thing that I mentioned was the property tags. This is a property tag. It is an enum. It actually has its own macro that you can import. The import process is very similar to structure, add enum, add standard structure by enum name. Only instead you would go by, instead you would do add standard structure by symbol name, and then you would type in the name of the macro symbol, which in this case would be macro PR entry ID. So that's kind of an intro of how to fix COM objects. Now I'm going to do just a brief run through of the actual COM object code and how it works. So this code is obfuscated if you kind of look at my graphs view. Deobfuscating is not within the scope of this talk. So I've just kind of gone through and commented where the next code block is on the line. And so at this point in the code, these functions have been imported and dynamically imported and then saved into heap at these specific offsets. This is important because they will be used extensively. So if we follow this first bit of code to the actual first block of code, we can see that the very first call that's called was the mappy initialize call to increment the mappy subsystem reference call. So this allows access to the mappy subsystem. And if you think of the mappy subsystem as like a giant database, the next bit of this analysis helps quite a lot. But so first the connection to mappy is initialized, and then we go into the next bit of code where it calls mappy admin profiles, and this creates a profile administration object so that it can actually begin enumerating all of the profiles that exist in Outlook. This is the iProf admin COM object, which if we look here, we have it imported right here. So from there, since there were no issues, it should return 0. And we will go to the get profile table call, which is actually what we were looking at before. And so this one, since it's not very clear on MSDN all the time, it should be noted that when this is called, a new COM object is also created for the iMappy table COM object. But essentially, this just creates a table of all available profiles on the Outlook device with the PR display name and PR default profile. And if we look up here, we can see that the property tag PR display name was added to a property tag array. So we can see that it's probably going to be extracting the display name from this get profile table, or from this profile table. And so if we're moving through the code again, we can then go to a function that it does actually enumerate the profiles. And so this will be another example of fixing COM objects and also fixing enums, because as you can see here, nothing is fixed. So this is an iMappy table COM object. So if I select this, I go to structure offset and then find iMappy table. We can see that that is set columns. Then if I go to here, iMappy table. And there are ways you can use key shortcuts to shorten this, but I don't know what anybody's default key shortcuts is, so we're not going to cover that. And then, so here we can see that it's actually just setting the columns to the specific property tag array that was imported, which was this. And then it's querying the rows and waiting until there's no rows left. And if we wanted to see what the return codes were, if you select symbolic constant, you can actually start to use the enums that you have. And if the symbolic constant doesn't exist in enums, you can search for them use standard symbolic constant, which will actually search for all of them. It's very helpful. And so this kind of just fixes up the function to make it easy to read. And you can very clearly see that it's just setting columns and reading rows. So now if we go back, so it enumerates the profiles. And then if we are looking at the next bit of code, once it's enumerated the profiles, it begins to actually steal from these profiles. So it enters into a little tiny loop where it walks through each profile that it's found and steals from them. So entering into the actual steal from profile function call, the first thing that we see is just like in the last one, it declares the property tag array. This time with the PR entry ID, which will be the entry ID for the IPM subtree root. So if we go to the next bit of code, we can see that the very first call that it makes is that it calls mappy logon ex, which will actually log onto the logs the client application onto the session with messaging system. And it sets the following flags: MAPI no mail, MAPI extended, MAPI new session. This will just kind of give it a very hidden access to the MAPI subsystem. And additionally, it sets the iMAPI session COM object for this. And then so from here, we can see that it starts to actually enumerate the message stores, which contains information about the emails, and all of the message is stored in the session profile. And so with this call to get message store table, we get another COM object to iMAPI table. And we begin to enumerate message stores looking for the PR entry ID that was declared up at the beginning. So once we have enumerated message store, it then goes on to open each message store, which gives it access to the iMessage store COM object for further access. And then it goes on to the next bit of code, which will open access to the address book for the profile, which has all the emails in it and email addresses, sender, recipient, etc. And so now it enters into the main wrapper for stealing from IPM, which is the main root directory for MAPI. So right at the beginning, we can see that another property tag array is generated, this one for the IPM subtree entry ID. And so moving through the code blocks, excuse me as I take a drink. So first, it calls get props to get the properties for the IPM subtree entry ID. And from there, it then opens the entry for the IPM subtree entry ID to identify the IPM subtree entries. And then from there, it actually begins to open the property for the container hierarchy, meaning it opens the properties for all of the folders inside of the IPM subtree. And then from there, it begins to actually extract the display name and the entry ID from the subtree folder list in that parse table function with the COM objects that have been fixed. And then from there, if we follow this down, the obfuscation is quite annoying. From there, it actually opens the entry for each individual folder in the IPM subtree root. And then it begins and it compares, and so when it calls open entry with this for containers or folders, it opens the iMAPI containers COM object. And then it actually looks for that with the comparison to the object type. And so once it is identified that it is looking at a folder, it begins to steal attachment emails and match them to the address book. And so this one is kind of simple. It's just a little wrapper to identify the emails, which it moves through and calls steal email. So in steal email, this is the core email theft code. This is where it actually does the act of email stealing. So at the very beginning, it first creates a property tag array for PR sender entry ID, PR sender name, PR sender email address, PR sender address type, PR received by entry ID, PR subject, PR body HTML, PR internet code page ID, and then PR message delivery time. And so this is one of the first set of, I guess, tables of sorts that the email stealer creates when stealing emails, and this will be saved to a file when it has found an email address. But so first it grabs all of those from the table and then begins comparing the returned output. So first it's looking just to make sure that the property sender email address exists in the buffer. And then if it finds it, it then begins looking at that email address, and it checks to see if it starts with SMTP. If it does start with SMTP for the sender email address, it will then dig into it and it'll try to find both the SMTP address along with any alternate addresses that this address might have. And that'll be logged to a buffer in heap or a buffer in memory. And then it does the exact same process a second time and then after that, it then creates a new table, this time querying the address book. So it's going to go for PR entry ID, display name, email address, an address type, and it does the exact same thing that it just did before with the sender email addresses, only this time it's with the email addresses in address book. And so it does the SMTP comparison to steal alternate email addresses, which are then saved to a buffer in memory. Moving on from there, if we scroll down a little bit, it then starts to actually look at the big email table, and it says to do some more comparisons on the content of the email. So it looks to make sure that there's a subject, and if there is, it gets transferred to heap. And then it also looks to make sure that there is the tag body HTML, which isn't the same as the body tag. Body HTML has all of the HTML code and is a different tag than the normal body tag. And so if that exists, it then checks the internet code page, and if it is in UTF-8, it'll then convert those to a saved Unicode for ease of transmission, and then that will also get transferred to a heap buffer. And then from there, the email stealer will actually move on to the act of stealing attachments. This is kind of interesting because this is a new feature for their email stealer. Actually, when I first analyzed this, I didn't realize it was new. And so the next day when somebody was like, hey, it's stealing email attachments, I was like, that's new. So that was unfortunate. But so this is first, it creates a table of the PR attachment content ID, the attachment MIME tag, the attachment file name, and the attachment data. And then it begins to actually validate and check those fields. So it checks that the attachment content ID exists. And then it also checks that the attachment data exists. And while parsing through that field, it in the PR attachment data returned field, at offset +8 is the size. And so it compares that size to a hard-coded value of 131,072, which was discussed in the slides. And then if it finds a file that is below that, it then parses it and steals it and saves it to a buffer. And then all of the attachments are saved to the same buffer that the stolen emails and email addresses are saved. And then it actually does something kind of unique. If anybody remembers, in the older email stealer, it used to check the delivery time and look for past 6 months. And if you look at it, it looks like it should do that. So you see that it checks for the PR message delivery time, and then it converts the time to seconds since 1970. ECX would get second to last, which is the return value. It calls it right here. And then if we watch ECX, they don't do anything with it. It just gets overwritten right here. So my thinking is that originally they were planning on checking time, and then they just decided not to, and they didn't remove the actual bit of code. It's just an interesting little tidbit. But then, so after they have checked the time, they then begin validating the information that they've gathered. So first, they validate that they have stolen email addresses. They also validate that they have stolen email addresses from address book. They checked that the email contains the body HTML data. And if it doesn't contain any of these, all of the emails are dropped, or the emails that have been stolen are dropped. But if it does contain all three of these, it then hashes two of the buffers, and then it stores them together to get kind of a unique ID. And then it stores that buffer it stores that hash value in a buffer in memory, and then compares to find any duplicates. Any duplicates are dropped, as you can see right there, drops any duplicates, and then all of the other ones, the non-duplicates, are saved to memory, which are then saved to a temp file, and then are exfiltrated by the module using the wrapper DLL code. So this, and if we go back here, we can see it kind of just cleans up the steal attachments. And if we go all the way back here, that's essentially how Emotet's email stealer steals emails. So hopefully you learned some things about the email stealer and how it functions, and also hopefully you learned some things about fixing MAPI-COM objects. I seem to be finishing up a little bit early, but I'm going to open it up for some questions.
So James? Right?
Yeah.
Okay. So yeah, I have a question or two for sure. Right. Just to quickly start with a general question regarding the Emotet as such. I mean, Emotet has been a very successful campaign. It's a very successful malware. What is your approach? Why they have been successful with what they do? Is there something very novel, or is there just something we're not looking for?
So the use of the reply chain, or the reply chain hijacking is a very convincing method of infection, in my opinion, because it looks like it comes from a legitimate source, and it looks like it comes from a conversation that you've been having with somebody else. So that's a very legitimate, that's a very effective form of infection. And I think that's one of the things that's led to it being very effective, but also just some of the generic templates, looking at them that I've received from my bots, I can see the average user falling for them. It's stuff like, it'll fake a password reset and it'll ask you to open a document, and the email addresses that it'll be coming from will be like, it'll fake like a password lockout for gmail.com, and it'll make it look like it's coming from a gmail.com email address. So if you're not actually checking the from headers religiously, you might end up getting tricked, and it only takes once.
Right. Do you know if the authors support multiple languages? I mean, if they need to trick the other user, they would require to write it in the user's language, or they will just steal the email, steal the content, and just do the attachment there or modify the content there on the fly.
So from what I haven't been able to confirm if they changed the language for the hijacked reply chains. However, for the generic templates, I've seen it in Finnish, I've seen it in Swedish, I've seen it in Dutch, I've seen it in Korean, I've seen it in Chinese, Japanese, I've seen it in, I can't tell if it was Russian or Ukrainian. I've seen it in virtually every single language in Europe. And then I've seen it in Spanish. There's, of course, English templates. I see a ton of Brazilian Portuguese as well, which is kind of interesting. So they have templates for virtually every single language. I can't speak on how well translated the templates are, but I do know that they at least exist.
Right. So you mentioned in your talk, and you explained that the attachments are being stolen. So are they being stolen and extracted to the location controlled by the malware authors, or it's being collected there on the compromised host for later extraction?
So when it actually steals the attachment, it gets added to the memory buffer and then gets saved to a temp file. And then the actual module, the wrapper that surrounds the decrypted DLL that we looked at, that will actually take that temp file and upload it to the C2. And then you will actually see those attachments reused in emails. I shared the gripper at Proofpoint. If anybody is interested in reaching out to her, can give you some very interesting statistics about how often the attachments are reused. But essentially, what we'll see is that on the reply chain templates, and also kind of the generic templates, occasionally you'll see attachments that are just put there, which could be kind of, and they seem to be attachments from legitimate sources, like they aren't malware attachments. So it kind of adds a little bit of a point of worry for anybody who has to deal with GDPR, or anybody who has to deal with any confidential information, because if you get that stolen and then it gets reused and sent to 20 people who aren't associated with the conversation chain, that's a huge problem.
Right. Do we have information if they reuse the attachments they've, or the emails they have, email attachments they have hijacked? Do they inject anything into those attachments before they are being sent out again and reused? Do they also collect information? Okay, that we might not even know, but they might process the attachments for sensitive information as well.
So I haven't seen, that's what I've been waiting for. I haven't seen any instance where the actors have injected malware into the stolen attachments. However, that would be the next step. And I also don't know if they actually do scan the documents for any personal information. It could just be that if it's a document that gets shared a lot, like security policy, they could just use that as a statistic for if we should reshare this document or not. But to be honest, I don't actually have any confirmation on when they decide to reuse the attachments, just that I've seen them reusing attachments.
Right. I mean, and you mentioned that there has to be multiple criteria met before the attachment is being, actually the email is selected and the attachment is being extracted. One of those being also the size of the attachment, which is, in my opinion, I think it was a relatively small sized, so they go for large ones, right?
Yeah, it's very tiny. Like most giant Excel files would easily be larger than 131 kilobytes in size. So it's a very small size that they're looking for.
Right. So most likely there's a place for the security analysts to analyze what actually that means and how this can be potentially used by the malware authors who are running this this network. Now, with this, thank you, James, for a very deep dive into the Emotet stealing module. It's been a really opening and enlightening for me. Thank you for this, and I hope to see you very, very soon.
Yeah, no problem. Thanks for having me.
Thank you, everyone. Thank you, everyone. There is still some things that we need to wrap up. We are going to cover also the CTF. The CTF is going to be concluded in less than 13 minutes. At 1700 local time, we will learn who is going to win the cyberspace. There has been dramatic changes over the past 2 hours, and let's stay tuned. At 17:05 in 20 minutes, we are going to take a look at what has been happening during the day 2, and we are going to announce the winners as well as conduct the awarding ceremony. See you very, very soon, 17:05. Stay tuned.